Live. All right, so today I want to talk about, or should I say, I'm going to go over this Python lesson that I created for my wife back when she was on mat leave. And I thought, why not just stream it as practice for streaming? So here I go. So the first thing we want to get started with is to make it as simple as possible. And instead of installing any fancy tools, the simplest thing is to install something like PyCharm, which has most of the stuff that you need to get started built into it. There's a free community edition, and that's pretty much what most people, if they're just starting out, will be good with. So yeah, just download PyCharm. It has all the things that you need to do to install it. It's right here in the installation instructions. Let me just increase that and get myself out of the way. So here the installation instructions are linked on their webpage. Pretty simple. So get it. Let me just gonna move some stuff around so I can see things better. All right, sweet. I'm talking to nobody, so that makes it a lot easier. So what I'm gonna do is run PyCharm. So I already have all that installed. It's just launching PyCharm right now. All right, so this is what PyCharm looks like when you first get in. There's a projects tab here. So I'm just gonna create another project from scratch. So file, new project. I'm gonna call this streaming, blah, blah, blah. Everything by default is okay. So just a pure Python application called streaming, because that's what we're gonna do to get learning. Let's go for this window. So it's going to create a new virtual environment. So this is getting all the binaries and all the executables it needs in order to have a complete environment to run Python. So Windows here, I'm not sure if you can see, but in the lower right hand corner, it's just saying that there's some file operations that are slowed because of Windows Defender. You just fix it, configure automatically. And it's done since there's no files. So the first thing I'm going to do is just create a new Python file. Let's just call it main. Very original. The next thing I need to do is inside PyCharm is I have to define how I'm going to run it. So just go up here, this little top left hand corner, there's add configuration. I'm just going to add a new Python. And then over here I can just decide where the Python application is. So I'm just going to wait for this to show up, and just main goes over here. And let me see if I can enter presentation mode. All right, so I'm in presentation mode. And if I hit run on empty, nothing happens because we have a blank page. So this is going to be a very basic lesson geared to someone who pretty much doesn't know anything about programming or any computer stuff in general. So basically my wife. So Python is a programming language, and to get into a little bit more detail, it's an interpreted language, meaning the computer reads line by line and it follows the instructions that you tell it right from there. It's a little bit more in depth than that, but in a sense, that's what it is. So you pretty much have to tell the computer what to do. And if you hit run on an empty, we get our output over here in between this line here. Nothing happens because we haven't told the computer what to do. So basically you enter text in here and the text has instructions. Now, if I do something like that, it's gibbly gobbledygook. The computer doesn't understand it and it throws this scary warning message or error message saying that it has no idea what's going on. So in something like programming in Python, there's a set level of instructions that you can give it and a set level of code, and it follows that. So you just obviously can't just put stuff in there like computer open the file. Like, that's not going to work. Imagine if it did. Yeah, things like that, which is very intuitive to humans, the computer doesn't understand because it only thinks in certain operations, and those operations aren't in Python. So Python is just a way to bridge between the computer and the human speech, the human way of speaking in English, that is. So I'm going to do something that's not going to cause an error, and I'm going to put this little, just blow that up a bit. Can I see it? This little hash symbol here. This is a comment. So if I go to run and run main, again, nothing happens, because what this is like I said, it's a comment, and a comment in computer programming terms is a way for the programmer to annotate the code that they write, because sometimes it's not obvious what's going on because there could be complex operations. It's just a way to sum up that piece of code to say, hey, this does this, or please look at that. And that's important because most programmers don't program alone, or even if they do program alone, they might write a bit of code and come back to it and not quickly understand what's going on. And it's just a way for mental breadcrumbs to be kept so the next programmer or even yourself are able to understand what's going on. So that is the comment. Just switch things around here. Where am I? Just in case anyone watches, which I don't think so. It's like midnight at this time. Everyone's asleep, which is the best time to teach and talk to nobody. The next step is the actual command. And this command is called a function, which is not too important what that is at the moment, but what I'm going to do is I'm going to issue a command to the computer, and the computer is going to follow that command. And that command is a very basic print. So if you kind of guess what this is going to do, this is going to print hello world on the screen here. So what this is a function, and a function is pretty much a command that is stated here. So print is the command, and then you'll see that it's wrapped up in these ellipses, or the little circle brackets over here. So the function here takes everything in there as a parameter, so that's input into the function. And in this case, double quotes, which is called a string. So anything inside those two double quotes is considered one unit, and it's a string of text. So I'm passing in this whole piece here, this string, into print, which accepts one parameter. So it's the most basic function that you could think of, and it does exactly what you expect it to do. So that was lesson 1.1, which was to get something on the screen, which could be a little bit harder than you expect, because if you miss certain things, where the heck did my cursor go? If you miss certain things, like for example, at least the IDE actually tells you what's going to happen. A little red thing there says there's an error about to happen. There's an error. So usually these things are somewhat helpful. It says line 3. This here, unexpected EOF, which means end of file, while parsing. Parsing means reading through the file. So it's seeing a end of the file before it can actually finish parsing. So it's expecting something there, and that something there is this. And then you let's say if you miss that, it's going to give you some other error. So this is a syntax error, and syntax is a way of the computer to understand the formatting of the command that you're giving it. So adding that follows the expected format, the syntax that the computer understands, which is the statement, which is the print, followed by the parameters, which are wrapped in those brackets or the braces, what are they called? Parentheses, and then the string wrapped in the double quotes. The next, we're going to go into variables. So if you remember from math, a variable is a holding spot or a holding place for a value. And in Python, it's very much the same, where a variable, so we'll call our variable, let's call it words. A variable is a holding spot for value. So if I create a variable right here, I can assign, which is put value into that variable, which is words. And I'm going to put this is in the variable. You'll notice there's a little squiggly line here. Python kind of likes the way you format things, so it wanted a end line here, or like a blank line at the end of that. It just likes things certainly formatted in white spaces vertically, so that's what it was doing. So I put this string into that variable. So now words, which is kind of like a bucket, is holding that. And if I run it, it's going to say this is a test string. That's because it goes through from top to bottom. So it ignores all the comments, anything with a hash, and executes that command, then goes to this, and this command just says put this into that, which is what that equal sign does. And then after that, nothing else. But if we do that, we start all over again. It goes from top to bottom. This is a text string. This is a variable. Pops into there. So very simple for the most part. It's just running through the code from top to bottom. The next thing we're going to do is take a look at what else can we store in here. So I'm going to call it num for numbers, or number. So again, notice how there's no double quotes around here. Anytime you put double quote around a piece of text here, it treats it as a string. So one piece of text here, and if you don't, it treats it as a number. So over here I put a number here, and then again if I do print num, it's going to show 199. Very simple. But what happens if I do num again? Let's make it something. Let's call it num. Jeez, numtext 199. If I run that again, it's gonna, from the output, it looks very similar. I mean, not even similar. It looks exactly the same. It's doing 199, 199. So that's how it prints things. It just prints things without the quote. If you notice that I push in the quotes, there's no quotes on the output over there. And you can do some interesting things with variables. Let's call it num2, this is terrible naming convention. So usually you want to be descriptive with your names inside programming, but I'm not. I'm just going to say num2 because this short little example. If I do something like num2 is 200, and I do a print num, and you'll notice something called math over here. I can do num plus num2, and this is going to do what you might expect, which is take num, the value here that's highlighted, and add num2 to it, and then you should see 399. Nice. But what happens if I do num plus num text? Error, because what's happening is that it doesn't quite know what to do with this piece of operation between a number, and even though this looks like a number because it's wrapped around double quotes, it considers it like a word or a string, and it gives up. It doesn't know what to do. Luckily, there is a way to fix that, which is to use another function, which this is called nesting inside programming language, which is to put a something inside something else. So a function inside a function. So functionception. Boom. Doesn't like that extra space. So as you see, there's this function here is standalone, and this is also a function there. So I have a function, and inside that function it's calling something called int. And what int is doing is it takes this string and converts it into an integer, which is what these numbers are. They're integers, if you recall back from math. So it's going to put num, which is in our case 199, and it's going to attempt to convert this into an integer. And it is able to. 399, 199. Why did I do that? Num 199 plus, 199 plus 199 is 398. Yeah, so that might be a little bit hard to grasp initially. So let's do that in another way here. Let's call it num3 or num converted equals int num text. And I'm going to run this. So what this is doing is it is taking the input of 199, passing it into the function int, which converts whatever is in there into an actual integer, and then I'm doing a number plus that converted integer, and I should get exactly the same thing, because what this is doing is a substitution. If we're thinking about this in math terms, it's doing a, why am I doing that? Oops, control. It's taking this, and wherever it sees num convert, it replaces it with that. So that's what it is doing in a sense, which yields the same output. So let's not get too bogged down into functions within functions, but it is very possible to do that. And you'd think, what happens if I do this? An error. The reason why is because print doesn't actually return anything, and it's trying to put number plus something that doesn't make sense to the to the Python language, and it just gives up. So we know that int returns, as over here, it returns an int. So we can do mathematical operations on integers together, but we can't do mathematical operations between integers and strings. Even though the string looks like an integer, you have to pass it into a function that converts it into an integer first, and that is this guy over here. In fact, you can, where I was putting num text, I can put like right directly into there, and it will do the math operation for me. It will convert this into an integer, and it's able to do the math operations. And math operations can happen like that, which is for subtraction. Division is this guy over here, and then multiplication is the asterisk. So if I do something like that, it's going to go for order of operations, which is this times this, and then minus that. So whatever that value is. And then you'll notice that it all of a sudden puts a decimal there. So the reason why is because the division operation isn't actually a clean division, because there's going to be some remainders, and it does some rounding because integers are whole numbers, and that's what it treats it as. The next step is we're going to look at sort of programming in general, like what is some of the key concepts of control of programming. So one of them was just outputting statements and doing some math operations, but that's not really programming. That's pretty much just telling the computer what to do from X and Y, but not enough for a meaningful program. So in order to get to meaningful program, we have to control the flow of the program. So as I said before, the program runs from like top to bottom, and it just top to bottom end, and that's it. So the way we get things to happen is to control the way the program operates, and excuse me, the way the program runs. And those are things called flow controls. And the first one is the if statement. So I'm going to introduce the if statement by introducing this variable called x, which is a very fancy variable. And if I do something like x equals 10, that puts 10 into the value of x, and we can prove it by running print. There you go. Print outputs exactly what we wanted. So there's a statement called the if statement, which is simply if, and then some sort of statement has to happen. If x equals, so this is saying if x equals 10, x is 10. Let's break this down in what's happening here. The first is the if, which is the control statement to begin the command. If, and then it checks this condition, which is dry throat. I should drink water next time I stream. So if this is true, and you'll notice that there's a double equal here, and that's to separate it from the single equal, which makes x turn into 10, or put the value of 10 into x, where this checks to see if x is 10. And if it is 10, it will do every single statement that is indented within here. My gosh. So I'm going to run this over here, and what we expect to show is that it's going to go here, put 10 into x, print out the value of x, check to see if x is 10, and if it does, it's going to run everything that is indented on lines 9 and 8, and then it's going to run line 10. Yeah, that's cool. Well, what if I change not x to 8? So the way this should work is it puts 8 into x. It prints the value of x, which is 8. It checks to see if x is 10, which it isn't. So at this point, it will ignore everything indented in here and then go to this line, the one at the exact same level of the if statement. And without stating it, and if I was to state it explicitly, the spacing really matters, because Python looks at the indents and it says, okay, this is part of the true statement here and everything else is not. So if I run this, it's going to do exactly that. Print 8, ignore this because it's in the indent of this, and then go to here, because if x equals 10, which it isn't, it's going to ignore everything over there. So there's also something called ElseIf, which allows you to stack on additional statements. And then I'm going to put something called lower than. So if x is lower than 5, print x is lower than 5. And if I run it, it won't print this because x is not lower than 5, and it won't print this because x is not 10. So if I put 4, it prints the value, then it goes to here. Is x equals 10? No, skips all this, and then it goes to here, and then it will always print this because it's outside of the if statement. And to be clear, this adding a space there makes it clear. And then you can also just put like catch all other commands here, print. So the way this works is it goes into here. We call something called the else, which will execute everything that isn't these two statements. So the only way to get to this is if I put something like 9, because 9 is not 10, 9 is not lower than 5, and then it falls through to here else. Otherwise, that's also another thing you can call otherwise. It goes into this line here. So now we can get sort of the computer deciding how to react based on input, or should I say based on certain values of a variable. And the next concept that is also important for computer programming and computers in general is the what's called looping. So looping is a way for a computer to do something a certain number of times over and over and repeat actions, because sometimes, a lot of times, computer programs end up just taking data, processing it, take data, processing it over and over. And that's a big concept of programming. So ifs and looping. And let's look at looping next. So it's called a for. So for everything from 6 or so, okay, take a step back. There's a variable called x in here, and it's going to do something from 0 till 5, which is 6 times. In computers, we like to count from 0 and start from there. So when we say 6, it's not counting 1, 2, 3, 4, 5, 6. It's actually counting 0, 4, 5. Sorry, 0, 1, 2, 3, 4, 5. So I'm going to run this and then explain what's happening over here. So like I said, this function will give us numbers between 0 and 5, which is 6 numbers. And then it's going to run everything in between this indent here. So like I said here, it goes 0, 1, 2, 3, and it's going to print that statement there. And I can do any number of, if I do that, it's going to boom, boom, boom. Now there's something called nested statements, or should I say, I can put an if inside a for loop, or I can even put a for loop inside an if, but for this case, I'm going to put, so I'm going to run that, and let's look at the output. So the first one, it goes, it puts the number 0, then we, then ww, or we, www, and then it goes through this statement and checks to see if x is actually 0, and it is 0, so it prints that. Then the next, it doesn't, because it fails to meet that condition of x equals 0, therefore it just skips that and then goes back to the top, does it 6 times, so it's looping through this 6 times. So we've got the ability to loop and the ability to check a condition. And now we're going to do something as well. Let's go y, create another variable, and we're going to make it do math, because math is the cornerstone of computers. So I'm putting here, so y, and I'm assigning y is equal to y plus x. So the first time around is going to be 0 plus 0, then 0 plus 1, and then it'll be 1. So it's going to loop that condition over and over. So let's actually look. Let's actually get rid of all this, and then since we already know x, what x does, and we already know that it's going to print, and let's run this. So it's doing the math on adding the numbers of each of the loop over and over and over. So let me just print both of them at the same time, and let's make it just a little bit of simple formatting. So 0 plus 0, and then 1 plus 1 is 2, so it puts it in there, and then 2 plus 3, etc. So it's just doing the math into there. So if we can do something like if x, or if y equals x, so oops, okay. We're also able to compare variables to variables. And yeah, so they're the same on 2 of them. Super cool. The next is we're going to look at functions. So like I said, print is a function. It's a built-in function. Range is a built-in function, and that function int before was a built-in function. So that's already included into the programming language. But we can actually create our own function using something called define. And I'm going to call it linfunc. Let's just make it all lowercase. And I'm going to want a parameter. Actually, you know what? I can actually take a function. Hello. What if I do this? Let's get rid of this. If I do this, what the computer does is it goes from top to the bottom, like I said, spacing, but whatever. It goes from top to bottom, and it sees this, and it says, oh, this is a function. I'm going to store this away in memory and think about it later when I need it. And then it comes to here, and it realizes this is not part of a function because it's not on the same level as these lines. So everything in between this line and then to the left, whoops, I just smacked the mic. Everything to the left is part of that function, and everything to the right or on the same level as the def is not. So it doesn't consider that part of the function. So what I'm going to do is I'm going to run this, and as expected, it goes here, stores that away, says this is a function, and then when it gets to here, it's like, oh, what's this? This is linfunc. I'm going to run the code now. So it's going to go back into its memory and then start from linfunc and go the next lines until it reaches the end, which is over here, because there is no more statements of the same indent as that. And if I did something like, let's say, for in I, a lot of programmers use I as an incrementer. If I do that, it's not going to work because the indent is wrong. Actually, if I wanted to do something, there's something called pass, which is like, okay, I want it to do 3 times and nothing happen, which sometimes you do want to do, and sometimes you don't want to do. If I do that, it's going to do it linfunc 3 times. So what this does, if you consider where linfunc is, it replaces that with everything in here. So that's pretty neat. What if I did this? I added a variable to here, and then I print v, and then I pass that there. 0, 1, 2, 3. So what this is doing is it loops through here, and it says linfunc, passes the value of I. So the first time it's 0, goes to here. That actually v here gets replaced with 0, and then it prints it. And if I do that, it's going to do everything in the function multiple times. So you can even have, obviously, or not obviously, now we got a little bit of a confusing exercise to think through here. What is it doing? Is it goes, so 0, 1, then 0, 2, then 0, 1. What this is doing is when it gets to here, top to bottom, it sees everything in here that is within the def indent. It says, okay, that's a function. I'm not going to do anything. I'm going to store that in my memory and think about it later. And then finally, when it gets to here, which is an actual statement at the at this level, it will say, okay, I'm going to go through this 3 times, and each time I'm going to increment the value and put that into I. So it starts off at 0, 1, 2, and it runs this little statement here. And this statement here, the first time it's going to pass 0, so it sees that and it jumps up to here and it says, okay, 0, everything in between these brackets or these parentheses gets replaced with that number, and then it will execute these commands here. So the first time 0, it's not going to do anything because counting from 0 to 0 skips that. The next time it's 1, and it gets moved into here, and it counts 1 time, so it goes 0, 1, or should I say 1, and then finally it does that 3 times. So yeah, you can get pretty complicated in the way you do those loops, and I can even start throwing in if statements over here. And now you start seeing the semblance of programming, which is to get the computer to do things under certain conditions and to repeat them over until a certain condition is met. And in this case, the condition is it counts to a certain number. And that, so far, is the computer just doing everything predetermined by what was in the program, but we can do something to make it a little bit more interesting, which is once you throw the user into it, things get interesting. So something called input So what this is doing, and there is something else I have to do, but I'll explain that later, is it goes to input, and what input does is it sees that there's a text string here, and it's going to print that on the screen, but wait for your input. And so whatever you type or enter into the computer, it's going to return that and place it into that variable. So if I put 1, you picked 1. So it returns a string. Let me just put that space there. Oops, just put some formatting over there. So yeah, so it's like, I can do something like pick a number. That actually wasn't a number, which so I'm going to create a simple pick another number. These are like basic programs that I used to write when I was a kid, or which was the computer asks you for your name. What's your name? And then you would do something like print hi, and you'll notice that these are strings. I'm not sure if I mentioned it before, but this is called concatenation, which is adding one string to the other. It just simply appends it to that. So what's your name? If I put Lynn, pick a number 1, 2, this is hi Lynn. Very simple. You can even put the variable at the beginning of the name, like I put like hi Lynn, you picked num1 and num2. So as you can see here, this is a string, and then the plus just means glue that all together, and wherever it sees a variable, it unpacks it and turns that into a string, so it turns into one nice long string. So if I can do something like, what's your name? Lynn, 1, 2. Hi Lynn, you picked 1 and 2. What if I wanted to be a simple calculator? Your numbers added is, so I'm going to put result is, now I know that num1 and num2 are strings, so I have to turn them into integers using this built-in function, which looks through num2 And then the other thing I have to do is, now that this is a kind of an awkward thing, this integer plus this integer gives me an integer, but I simply can't just concatenate a string with an integer. I have to pass it through a function called str, which is string, and it turns that integer into a string. So the reason why is Python doesn't understand what you want to do with an integer and a string. It doesn't automatically know you want to add that together. So if I put len 1, 2, your numbers added is 1 and 2. Exactly what we expect. Now we can even do things like if result is greater than 20, we're going to for, and then I'm going to in range result print let's make something better. Let's print happy faces. So if I put my name is Lynn, number 10, number 30, it's going to print 30 happy faces if the result is greater than 20. But if I put Lynn, pick a number 1 and 2, 3, it doesn't. So that is pretty much the, hold on one second. That is pretty much a program inside Python, which is the basics of how a lot of programs operate. It's just combinations of for loops and if statements and variable assignments that get the computer to do things, and obviously functions. So certain functions are a lot more complex. They can draw pictures on the screen or play sounds, not just output text. And that's the very basic core concept of most computer programs. And in a sense, if you look at a lot of programs, they're just variants of this. So we can even have something like so this is another thing, which is let me call that, well, result. A while is like a for loop, but it just never ends unless a certain condition is met. So this says if result is lower than 10, it's going to keep doing everything in between the indent to the left of the while statement. However, if it's greater than 10, it's going to come here and not do it. So actually, you know what? Let's change that, because if we look at the logical thing here, this will never get printed, because if it's lower than 10, it's going to do that, and if it's greater than 10, it's going to stop and it'll never get to this part. So that's part of, let me put here, so if it's lower than 10, it's going to ask me again. Now if I put, it stops that and prints the last thing. So that is sort of the basics of programming, all the concepts that you really need to learn in, I guess, procedural programming, this is called, or where the computer reads from top to bottom and then it pretty much executes your statement as it sees it. It can get a little bit more complex than this, but that is programming 101. And hope you enjoyed that, to nobody who showed up, because it is, after all, 1 a.m. and hope you enjoyed that lesson. Bye. How do I stop this?